Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
This one question lost more marks than any other on last year's AQA paper, and it's actually easy if you know the trick. Imagine you're 3/4 of the way through a paper, you see a triangle, you write down the sine rule because you've seen it before, then you get an impossible value for sine and suddenly panic. That wrong decision just cost you method marks and time.
By the end of this episode, you'll have one reliable trick to decide between the sine and cosine rule. You'll hear a full worked example that shows the ambiguous SSA case, and you'll know exactly which steps get you method marks, even if you don't finish. One simple decision, identify the knowns properly, fixes most of the freezes. Let's work through this step by step.
First, the concept. The sine rule and the cosine rule are not magic. They answer different questions. Say you've got a triangle with angles A, B and C and opposite sides A, B and C. The sine rule says A over sine A equals B over sine B equals C over sine C. Say it out loud. A over sine A equals B over sine B. Use the sine rule when you know either an angle and its opposite side plus another angle or side. In exam shorthand, ASA, AAS, or the tricky SSA, where the angle and the opposite side are given along with one other side.
Why does that ratio work? A quick verbal justification. Drop a height from one vertex. The height is side times sine of its angle. The same height can be written using different sides and their opposite signs, so those ratios match. You don't need to memorize the proof at exam time, but understanding the height idea makes the rule feel logical, not random.
The cosine rule looks like a stretched version of Pythagoras. It's c squared equals a squared plus b squared minus 2ab cos c. Say, c squared equals a squared plus b squared minus 2ab cosine of c. Use the cosine rule when you know 3 sides, SSS, and want an angle, or when you know 2 sides and the included angle, AAS, and want the third side. It's the reliable option when the angle you know sits between the 2 known sides.
Why does it work? Think of Pythagoras. When the angle is 90 degrees, cos c is 0, and it reduces to a squared plus b squared. The minus 2ab cos c adjusts the Pythagorean result to account for the angle not being 90 degrees. In practice, if the angle is the one between the 2 known sides, reach for cosine rule. If the angle is opposite a known side, think sine rule.
Now, let's do a spoken worked example, the SSA ambiguous case that often trips students. You're given angle A equals 30 degrees, side A equals 8, and side B equals 10. The question, find angle B and explain whether there's one triangle or 2 possible triangles. Step 1. Choose the rule. We have an angle A and its opposite side A and another side B, so this is an SSA situation. Use the sine rule. Step 2. Write the sine rule out. B over sine B equals A over sine A. Rearranged for sine B, we get sine B equals B times sine A divided by A. Say the substitution. Sine B equals 10 times sine 30 degrees divided by 8.
Compute sine 30 degrees is 0.5, so sine B equals 10 times 0.5 over 8. That's 5 over 8, which is 0.625. Now here's the crucial part. Arcsine of 0.625 gives an acute angle, about 38.7 degrees, but sine is positive in the first and second quadrants, so there's a second possible angle, 180 minus 38.7, which is about 141.3 degrees. This is the ambiguous case. Both 38.7 and 141.3 give the same sine value.
Step 3. Check feasibility. Add A and the first B. 30 plus 38.7 is 68.7, leaving C about 111.3. That's fine. Add A and the second B. 30 plus 141.3 is 171.3, leaving C about 8.7, also fine, because all angles positive and sum to 8t. So both triangles are geometrically possible. You must report both solutions and show the check. If the second B had made the total exceed 180, you'd reject it. That's the simple test. Does A plus the candidate B leave a positive angle for C? If yes, keep it. If not, discard it. And always state both possibilities clearly in your answer when appropriate.
Now, the examiner's perspective, where the marks are. For a question like that, examiners award M marks for correct method steps and A marks for accuracy. A typical breakdown: M1 for writing the sine rule, M1 for the correct substitution, M1 for rearranging to the sine of the angle, A1 for the first angle answer. If the question asks about the ambiguous case, another M1 for considering the second angle and an A1 for its value. That means even if you can't finish the final arithmetic, those method lines are worth marks. Write them down. A practical tip: label your triangle clearly on the diagram. Write the rule you're using on the answer line and keep intermediate values, like sin b equals 0.625, visible. Examiners can award method marks just for that setup. If you get a weird value for sine greater than 1, don't rub it out. Write no solution with the calculation shown. That shows you've applied the rule and understood the domain issue, and you'll often pick up partial credit.
Write a quick win you can use immediately. 4-step checklist for every triangle question. 1. Identify knowns clearly. Write down which sides and which angles are given. 2. Decide the rule. If you have SSS or SAS, use cosine. If you have an angle and its opposite side, use sine. 3. When using sine, compute the sine value and check it's between 0 and 1. If it is, test both arcsine theta and 180 minus arcsine theta to see if a second solution is possible. 4. Always do the angle sum check at the end. A plus B plus C must equal 180 degrees. That's your 10-second check.
A second 10-second habit. Round at the end only. Keep your intermediate values, like sin b equals 0.625, exact where possible. Then give final angles to the accuracy the question asks, usually 1 decimal place for higher tier. Write down B approximately 38.7 degrees or 141.3 degrees. Check A plus B plus C equals 180 degrees. That one line often wins the mark when papers are being marked quickly.
That's your quick win for today. If you want a tidy printable with the example diagram, the full worked solution, and a 1-page checklist to stick in your folder, visit jcacademyonline.co.uk. You'll find downloadable resources that match this episode and step-by-step solutions for teachers and parents to use in revision. Share this with a friend who's revising. It might save them a mark or two on the day. Until next time, trust the process and nail that exam. Stay curious.